So this is chapter 6, section 1, roots and radical expressions. Our learning objective is to find nth roots. Nth. So not just first square roots, cubed roots, but any roots. That's what we're doing here. So corresponding to every power, there is a root. For example, just as there are squares or second powers, there are square roots. Just as there are cubes, there are cubed roots. And so on and so forth. So if a to the n power is equal to b, with a and b being real numbers, n is a positive integer, so let's put that positive integer. Then a is an nth root of b. So if I can raise a to the nth power and get b, then a is the nth root of b. Okay, so the positive root is the principal root. So the positive root is the negative root is its opposite. So if I'm asking for the negative root, you just put a little minus sign. That's easy peasy. We write roots like this. So we have the little radical sign. N is the index. The guy underneath the radical sign is the radicand, because he can. Radicand. And then this is the radical sign. Okay, so for those of you guys at home watching this recording, make sure you write this chart down on your note paper. Then we're going to use this chart to answer the question, what are the real fifth roots of 0, -1, and 32 together? So what are the real fifth roots of 0, -1, and 32? The real fifth root of 0 is 0, because 0 times itself 5 times is 0. The real fifth root of -1 is -1, because -1 times itself 5 times is -1. And the real fifth root of 32 is 2, because 2 to the 5th power equals 32. So now we're going to do what are the real square roots of 0.01, -1, and 36, 121. Okay, so when they're asking what are the real square roots of 0.01, it might be easier to see 0.01 as a fraction. So if I had 1 over 100, I can find the square root of 1 and the square root of 100. So the square root of 0.01 is 1/10, or 0.1. The square root of -1 does not have a real solution. It's I. And the square root of 36 over 121, square root of 36 is 6, and the square root of 121 is 11. Alright, so let's look at our find the real number roots. -27, the cubed root of. So what times itself 3 times gives us -27? Hold up a hand.
Wait, so it's a square.
So I'm looking at A, cubed root of negative 27
Is 3.
is negative 3,
Yeah.
and we're allowed to use, because we have an odd index, we're allowed to deal with negatives. So what times itself, so let's look at B. What is the fourth root of negative 81? What times itself 4 times? Boom, 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 boom. When I multiply that together, will give us 81. Negative 81. Nothing. Normally we would pick which number if it was just 81. We'd pick 3. But because it's negative, there is no real number root. All right, square root of negative 7 squared. That. So if we do order of operations on C, negative 7 times negative 7 is 49, and the square root of 49 is 7. And what about square root of negative 49? No solution, because it's negative, and our index is, what's the index on D? Square root has an index of 2. So if I have a base of A, it's being raised to the nth power and also having the nth root taken, it's going to be equal to A if n is odd. It's going to be equal to the absolute value of A if n is even. And that's just like this C from the last problem that we explored. So when we had negative 7 squared and then square rooted, we got positive 7. Okay, so in this next bit, we are going to find the square root, cubed root, and fourth root of 3 different expressions. Okay, so the square root of 81x to the 4th is 9x squared. The cubed root of a 12, b15, is a to the 4th, because I'd have to multiply a to the 4th times a to the 4th times a to the 4th to get 12. B to the 5th. So I'd have to multiply b to the 5th 3 times to get b to the 15th. So we want to think about our power divided by our index. So 12 divided by 4 is 3, and 16 divided by 4 is 4. Go ahead and take a minute or 2 or 5 and write your summary. Make sure it includes all the things that we've learned today and the learning objective.